Hello, my name is Henry Huang. I'm an investment director with TDK Ventures. I cover investment in computing and connectivity. I would like to thank everybody for coming to attend our flagship annual event, DX Week 2023, a thought leadership gathering in the DX communities. The reason that we organize such an event is really to bring together the innovative community in the DX. As Nicholas mentioned earlier, code of conduct, contributing to society, delivering insight, last but not least, entrepreneur first. All the guests here are close friends of TDK Ventures. I know people come all the way from East Coast, New York, Boston, DC. Thank you for coming. And there's a group from Southern California as well, San Diego, Los Angeles. Thank you too. Many more are local partners that we work together on all kinds of projects. This is, for us, we hope that to have a platform to share insight and ideas will bring up new investment opportunities, collaborations with different opinions coming from industrial, academia, startup, and VC communities. I would also mention that we have an online audience here, which have a even broader reach. As far as I can see from registrations, there are people coming outside the United States. On the stage, it is our honor to have three distinguished speakers. All of them have decades of executive leadership in the area of DX, especially computing and connectivity. I would like to give a quick intro of our distinguished speakers. Start with lady in the middle, Diane Bryan. Diane is a global technology leader in semiconductor industry, cloud computing service, AI application, and technology-based healthcare solutions. Diane currently serves as the chairman and CEO of Nova Signals, a medical technology and data company focused on brain health. Applying robotics and AI with the direct access to cerebral vascular data enables diagnosis of stroke, traumatic brain injuries, and other diseases. Prior, she served as the Chief Operating Officer of Google Cloud, where she focused on optimization of global supply chain, acceleration of customer adoption, and the development of next-gen IT solutions. Prior to Google, Diane spent over 30 years in Intel, with the last position as the group president of Intel's data center group. This worldwide organization develops server, storage, network platforms. Before that, Diane was Intel's corporate VP and Chief Innovation Officer. Diane served as the director of the board for Qualcomm, for Broadcom, sorry. we have more Qualcomm folks. And she's also the chair of the UC Davis Chancellor Board of Advisors. Diane was named one of among Fortune 50 most powerful women in business. And she established the Diane Bryan Engineering Student Center at UC Davis. Baker's Healthcare named her one of the 7 shakers and movers leaders in health IT. Business Insider ranked her one of the most powerful female engineers. World Affair honored her with its Global Citizen Award. So Laurie, the lady sitting first to me, she's a general partner at Playground Global. Thank you for co-hosting this event. An ambitious problem solver and prolific connectors by nature, Laurie has decades of experience building, scaling, advising companies from early stage to multinational companies. Laurie was a board member and an advisor of autonomous mobility leader Zoox from early stage to the acquisition by Amazon. Laurie also was a founder and managing director at Growth Point Technology Partners, pioneering technology investment bank, where she helped entrepreneurs and board to complete strategic M&A transactions. Laurie was also a founding investor and board member at Tesla for almost a decade. Last but not least, Dr. Paul Jacob founded XCOM in 2018 to keep inventing and to invest with the world's most creative engineers and business people. As former CEO and chairman of Qualcomm Corporation, Dr. Jacob spearheaded its effort to develop and commercialize fundamental mobile technology breakthroughs that fueled the wireless internet and smartphone revolutions. During his tenure as CEO, Qualcomm revenue quadrupled and his market capitalization doubled. Dr. Jacob is a prolific inventor with over 80 US patents in the field of wireless communication and devices. He's a director of Dropbox, ARM, and First. He's also an owner and vice chairman of Sacramento Kings NBA team. He attended UC Berkeley, where he earned BS, MS, and PhD in electrical engineering and computer science. He founded Berkeley's Jacob Institute for Design Innovations and was the university's 2017 Alumni of the Year. Dr. Jacob is a member of National Academy of Engineering and fellow of the American Academy of Art and Science. Wow, such a... Thank you, Paul. Thank you, Laurie. Thank you, Diane. I would pass the mic to each of you to tell the audience a bit more of yourself, your personal journeys along the DX transformation, and the exciting project you are working on right now. I probably will start with Laurie.
Hi. First of all, welcome to Playground. I hope you are enjoying getting a chance to see our facility. So we are a early stage deep technology venture capital firm with over $1 billion under management. We have 5 partners, but we also have 40 other operating professionals, mostly technologists. So we help companies develop their software, their architecture, do prototyping. In our prototyping lab, we help companies with industrial design, with recruiting, with organizational development, with marketing, with PR, and with all kinds of engineering architectural problems, even with manufacturing issues. So as you see around the building, there are lots of folks working with our tremendous portfolio companies. We have over 50 portfolio companies that are currently active. And we invest in 5 areas. So next-gen compute and quantum computing is one of them. Then we also invest in engineered biology, so seeing engineering and AI coming to biology to solve problems. In logistics, automation, and robotics, so you might see some robots roaming around the building. In decarbonization, and in software infrastructure in areas like AI and cybersecurity. I actually started my journey as an AI programmer in the 80s, so it's quite fun to see what's happened with programming. Spent the 90s at Sun Microsystems, and then Paul hired me to work for him for a while at Qualcomm, which was wonderful, and I met Diane many years ago at Intel, so it's a great honor to be on this panel with such esteemed colleagues.
So it's my first foray into the healthcare world, which is incredibly complex and can be incredibly frustrating. But we have a robotics and AI-driven platform that diagnoses illnesses of the brain, and we're starting with stroke. So it is a lot of fun. Always need capital. Anybody out there? This is going to be a full day of pitch for me. So always need capital and or acquisition if you know someone who wants to buy us.
Anyways, yeah, so XCOM. So I started XCOM with a bunch of people that I had worked with at Qualcomm. Kind of came out of, we tried to take Qualcomm private. It was definitely mispriced by the market, and we didn't quite succeed, but as part of that, we gathered a group of people together that were sort of the people I had worked with for 30 years, designing the next new wireless technologies. And I like the saying, the best way to predict the future is to invent it, so we should keep inventing. So that's what we did, and we've actually figured out some pretty cool stuff. We've used a technique called joint processing, which means you process all the radios together, and you can get dramatic improvements through separating the user devices spatially. So anyways, we'll talk a little bit more about that, but it's nice to be at a computing and connectivity conference because that's exactly what we're doing. So yeah, and anybody wants to give me money or buy my company, me and Diane are selling.
Thank you, Paul, Diane, and Laurie. I learned something new about you. I'm sure the audience also appreciate you sharing the exciting project you're working on here. Since all three of you have decades of executive leadership and made big impact to the computing and connectivity industry already, I will start the first question as, what do you think is the most impactful innovations in computing and connectivity in the next 5 years? Maybe start with Diane.
We're going to talk so much about AI and ChatGPT and cybersecurity. It's impossible to avoid that conversation. But when I think about the tremendous growth that we've seen in actual real-world deployment of AI over the past few years, it's dramatic. I mean, I remember the first time I got up on stage and said artificial intelligence, and you actually had to say artificial intelligence. You couldn't say AI, or no one would know what you're talking about. And that was 2013. So now here we are a decade later, and the adoption is real. What, though, comes with that, and I think John was talking about earlier, is the compute platform it runs on. I mean, right now, NVIDIA is the platform, right? And the price of the GPU platform has gone up and up and up and up, and NVIDIA stock in 2019 was $30. It's now $300. That's a pretty big gain. And so I think the innovation in the next 5 years has got to be a competitive platform. So number one, a competitive platform to NVIDIA's. And it's hard because it's a very sticky platform, but you can see the investments that Google's been making in TPUs over time, right? AWS coming out with their own AI processing, matrix multiplication solution, but they're not at the competitive performance level of NVIDIA. And I think you're going to see a lot more custom silicon coming out of other large cloud companies like a Facebook or whoever, or cloud service providers. It's inevitable because it all goes back to efficiency, and it's incredibly inefficient because of the price that you're having to pay for the compute power. So I think anyone that is, I know investing in silicon is hard because it's expensive and investors have to have a lot of fortitude, but there's gonna be a real appetite for acquiring companies that have innovations around the hardware space in AI. Those big guys are gonna grab them, and then they're gonna scale the platform and create some real competition. They have to.
Yeah, it is very insightful, and a competitive platform for NVIDIA is a big take. As NVIDIA really have a very strong foothold in the industry right now. So hearing that, Paul, I want to move the mic to you, and I want to make it a bit harder for you. It's not just the 5 years. I would also ask, what is the most challenging innovations but will disrupt the market in 10 years? So both 5 and 10.
Oh, 5 and 10. Okay, well, so 5, I was going to say for 5 in the industry that I'm involved with, so the wireless telecom industry, we've gone through a set of different innovations to try and get the efficiency of the networks up and support all these cool things that now we've gotten to a point where we're actually moving the processing out of the end device and into the edge of the network, and that lets you do all sorts of really cool things. With XR, we're actually doing split rendering so that you can get photorealistic images on the devices on your headset, which you can't do because the headset itself is too constrained, but if you do it in the edge, you actually can get photorealism. And not only that, but the joint processing we do is also something that's the wireless network itself is in the edge. So I think that in 5 years in our industry, it's this joint processing and moving processing to the edge. In 10 years, look, also with my industry bias, the most valuable company in the world is based off of selling smartphones. And I think 10 years, I think maybe we will get to the point where the smartphone will be challenged by other devices that are more body worn. Right now, obviously, they're big and dorky looking and all, and there's not a lot of applications, and the applications don't really let you work with each other, and they're not very realistic. You're talking about cartoon characters and all this stuff. I don't believe in those kind of things. I think that as soon as we get to real reality, a realistic representation of reality that you're interacting with both in real life and virtually, then it's going to be something that's important and life-changing, and the kids are going to adopt it in ways that we didn't expect, just like they've adopted all these other technologies that we didn't believe that somebody was going to sit in front of their computer all day instead of going out and playing with their friends. But that's exactly what my now 20-year-old did, and there's going to be the kids, in the future that are just going to live primarily in a very digitally mediated world. And 10 years, I think, that's probably about the time frame that we'll get all those pieces put together by.
Yeah, it is very true. I remember that my daughter, 13 years old, had a birthday party. Friends invited her for a birthday party, which goes to the AR, VR gaming places, which is really cool, and they show the pictures.
The one that we were working with used to make you carry around 22 pounds of equipment, so little kids were definitely not into that.
It is. So that's why I think the game doesn't last very long.
And the battery doesn't last that long in the backpack.
It is. So, Diane, you hear Paul mention the XR and novel edge device. What is your take on the 10-year question?
Yeah, so I do think the 10-year number is key because we've seen over and over again, it seems to magically be a decade that it takes everything to go from introduction to mainstream, so from nascent to prolific. Cloud computing is a great example. It was 2007 when AWS knocked on Intel's door actually and asked us if we wanted to partner on this thing called renting out hardware infrastructure, and we said no, that sounds silly, and that's AWS. So that was 2007, and it was really not until 2016-17 before real enterprises were deploying real apps into the cloud. So everything takes a decade. Everything, internet, phones, everything. So I think the easy, simple, obvious answer is take anything that is nascent today, and in 10 years that will become prolific. And you have to say, well, what's nascent today? ChatGPT, right? It's all generative AI. That's what everyone's talking about. And I do believe, as John was talking about, there are real applications and real ways that it is going to drive efficiency. And I'm always hung up on the word efficiency, because if you can make something more efficient, you're going to be successful. I think as a data point, the IBM CEO said a couple weeks ago that 26,000 IBM jobs are going to be replaced by generative AI in 5 years. I think 5 years is a little aggressive, but they have all reasons in the world to get you to think it's going to happen in 5 years. But 10 years, So I think a decade's a magic number.
And I'm
Go
happy
ahead,
to take those
please.
questions as well for the 5 and 10 years. In 5 years, I would agree, and I will jump on what Diana's been talking about in terms of new computing architectures. We saw, first of all, AI happening with regards to actuation, so the digital world meeting the physical world. And I know in the last session we talked about autonomous vehicles. We saw a lot happening in computer vision, and we saw that helping through actuation the whole robotics industry and mobility coming out of that. And then as the neural net models got better and better, and as we started combining large language models with what had been done in natural language processing, we saw much more happening in the text space. And ChatGPT has provided a fabulous conversational interface so that the whole world is now talking about AI and playing with things like DALL-E for images and ChatGPT for text. But as Diane said, the compute required for all of that data and the architecture required for processing all of that data is tremendous, and the energy utilization in the data center is also tremendous, and the number of GPUs required. So as we were looking at Playground and looking at the 5-year period, we said, hey, we're going to need a much better architecture for faster inferencing, and the companies that want to build their own models and train on their own data are also going to need a training platform. So we invested in a company called D-Matrix that does an in-memory compute technology so that you have the memory and compute both in SRAM and can speed up inferencing at an order of magnitude with a far lower cost. And then as we looked at training, we realized these huge language models were going to be useful, and the very large corporations could build these very expensive models. I'm sure people have seen how much OpenAI is spending these days. But that many companies were going to want those domain-specific models that John was talking about. And instead of needing trillions of parameters, the sweet spot might be 3 to 50 billion parameters for domain-specific information that any enterprise might already have, and they may want to train on that. And so we invested in a company called Mosaic ML. It was, interestingly enough, the same team that had developed an earlier AI acceleration hardware technology called Nirvana Systems that actually Diane acquired while she was at Intel. And that team left and realized that there was so much to be done in software and building the software architecture and tools for training that they could turn 1,000 different knobs to optimize training. And so they created a company called Mosaic ML that is helping anyone, any enterprise, to build very, very efficient models and then train on them at a much, much lower cost and, very importantly, much, much less energy. So I don't know if you wanted me to take the 10-year one as well, or if you want to...
Yeah, go ahead.
Okay.
Go ahead.
And then another area we really bet on in the 10-year time frame is quantum computing. And so we invested in a company called PsiQuantum. So in quantum computing, we saw ion trap technologies, we saw superconducting technologies, and then we were looking at photonics. And if you think about silicon photonics, the semiconductor industry has learned the process for manufacturing and fabrication for the semiconductor industry using silicon photonics. So it's a very, very well-known technology. And so we thought in order to scale to a 1 million qubit quantum computer, which we felt was going to be needed for the reliability and the scalability that would be required for true useful quantum computing for companies to use, we were going to need error correction and felt a 1 million qubit machine was going to be what was needed. So we invested in PsiQuantum, who is working with Global Foundries right now, manufacturing thousands of silicon wafers to produce the first useful 1 million qubit machine. Actually, their company is right down the road from here, and we started working with them and are a huge believer in the different workloads that quantum computing will solve, which are going to be quite different from the AI workloads that are so data intensive. And with quantum computing, it's going to be more math intensive, so different applications.
Yeah, so what I'm hearing is quantum computing, domain-specific silicons, and the large language model and training and inference. I want to double-click on that. In the previous fireside chat, also touched with the advancement of the generative AI in the past 6 to 18 months really have significant improvement in terms of the technology and applications. With those large language models being trained in massive data and able to generate the natural language texts that almost like human right, how do you see the potential cybersecurity issues, and what are the unique cybersecurity concerns you see come out of it?
So cybersecurity is an area we spend a lot of time in it as well, and the potential for deep fakes. Think about those phishing emails that we used to get that had typos and spelling errors, and one of your closest friends was lost in Nigeria and needed help. And with generative AI trained on those large models, you would only need a very small excerpt of someone's text or video or voice to create a much more believable phishing attempt. So we're going to see much more sophisticated phishing, much more sophisticated ransomware, much more sophisticated spoofing of all kinds and spamming of all kinds. So generative AI does have that side where determining the authenticity and the provenance of content is going to be absolutely critical. And we're going to need to see new technologies in determining digital identity. If any of you haven't watched at the TED conference this year, a gentleman by the name of Tom Graham gave a quick demo and was able to use his technology to project onto the face of people in the audience someone else's face and show it in video in real time. And it was quite spooky, and it was able to take both voice and facial images and project them on anyone in the conference. If you haven't seen the demo, it's pretty scary.
I mean, it's not just cybersecurity, it's all security. I mean, if somebody can call up a financial, your financial person and look like you and say, here, transfer money to this account. I mean, it's we are going to have some digital identity solution. And, you can imagine that it being a situation where you aren't even you unless you have some digital token that proves it's you. And if you lose that thing, you got to go somewhere where they're going to measure your biometrics and make sure it's you before they give that back to you again. Because, this question of having something that detects a generative AI generated thing, that's how they're built. They have these adversarial things that try and detect and fool and detect and fool. So it's just, that's cat and mouse game. So there's going to have to be something. And then when you talk about quantum is going to screw up all that crypto stuff. So yeah, we got a lot of fun ahead of us.
So Paul, can you be more specific about what are innovations that you can see to solve this, rising security issues? Interesting technology you observed?
No, I think what I said. I think that it may turn out that we will have to have devices prove who we are, and losing that device loses your identity, and you're going to have to be able to go and get a new one right away. Because I don't actually know if you think not that many generations out of this technology, it's going to be seamless. And we've all put enough information out on the internet now that what we are appearing to say will sound like it's us saying it too, because it will have our mannerisms. So how you get around that, that's going to be a very deep problem to solve, and it's on us. This is not very long from now that this is a problem.
There are a few things that are being developed. First, if you haven't read the NIST, they came up with a risk management framework for AI, much like they had for cybersecurity. So there's a government effort. How many of you have heard of C2PA? No one. Okay. So there is a coalition of companies. It is called the Coalition for Content Provenance and Authenticity. So it was started by Microsoft, Intel, Adobe, Twitter, and other companies to develop technologies that could tackle digital provenance. And I was talking to Eric Horvitz on Friday, and he said they're actually quite a ways along. Of course, Google and Meta have their own efforts. As you can imagine, they've had to tackle this problem on their own as well. But he was actually fairly bullish, and many of these coalitions are involving academia and government and industry and scientists together to tackle these problems. They're certainly not going to be easy, as Paul said, but there are coalitions that are coming together. We have, as more and more workloads are moving to the cloud, we have a company that's called Anjuna that actually provides confidential computing for cloud workloads. We've had good network security for data in transit, and we've had other security for data that's in storage, and this is for data in use, and providing, much like VMware provided virtualization and containers for computing workloads, this is providing a similar kind of containerization for data in use. So there are some exciting companies coming. But Paul is absolutely right. Post-quantum cryptography is going to be an important field as well, as is post-generative AI identity.
Diane, you have anything to add?
No, just that cybersecurity, I completely agree with you. It's a huge problem. Security is a huge problem. Cybersecurity is a huge problem. Being in the healthcare space, those people are completely paranoid about cyber theft, given you're handling, PHI. Personal health information. So the willingness to adopt technology starts with the over-conservative view of the risk of that data. So it's until we get stronger security solutions that can give those high-risk industries confidence, like the healthcare industry, it's going to be an inhibitor for technology adoption, and hence our healthcare system today.
Yeah, sure. I'm sure cybersecurity is a very important topic in the domain of computing and connectivity. Now I would like to switch gear a bit. Pao, I know XCOM is really in the middle of computing and connectivity. What do you see the recent innovations that will disrupt the traditional industry? And would you provide some specific examples?
Obviously, everybody lived through the 5G hype cycle, and that hasn't really panned out. But what actually did happen that I think is super interesting in the connectivity industry is sort of different licensing models for spectrum and for licensed spectrum or lightly licensed spectrum. And what that's done is that's going to allow the market to move from selling to a few, handful of mobile network operators with tremendous buyer power to a much more horizontal market where you can sell into enterprises. And that's, it is starting already. One of the things that we're working on right now that's cool is on the warehouse automation, where there's big racks that have all the merchandise in it, and mobile robots are running up and down in three-dimensional space, picking stuff up, taking it to a picker, and then the order that comes in, 12 minutes later, it's available. And you can imagine from a radio standpoint, there's a three-dimensional metal structure, stuff moving around, metal things moving around, so the RF environment's changing dramatically, hundreds or thousands of robots driving through this thing. So they needed a specific solution. They didn't need a general purpose mobile network operator solution. Maybe they needed some spectrum, but they needed something that managed handoffs, or eliminated handoffs and had high spectral efficiency so we can get all the information to the robots and back, and had to be super reliable because these things aren't very big, so if the robots crash into each other, somebody's got to climb inside that thing and pull the robots out. And anyway, so there's these super interesting applications of a private network. And obviously there's much more mundane things like just going around and doing, inventory management, or going around your store and whatever, out of stock. And so in that logistics industry, and then of course there's all the utility stuff, there's factory automation, there's many things where there are companies that have a job to be done. They don't need the general purpose solution of a wireless system. They need something very specific and tailored. And so that, I think, is going to open up a lot more innovation in the industry, because it won't be this one-size-fits-all network. And so that's an area that we're super excited about, and it really did come out of having more leeway to get the spectrum, because while Wi-Fi is great, a lot of these mission-critical things, people are coming to us and saying, hey, we don't want to use Wi-Fi for this because it's not giving us the level of reliability that we need for this mission-critical thing. And so you want something like a cellular network is scheduled, and it's much more managed, and all of these things. So I think it's a big disruptive force in the wireless industry that will change things pretty dramatically. And then the thing that I said also, just this trade-off of using compute to get more efficiency of the network, because going back to spectrum, it's scarce and expensive and all those things. And so if you can use more processing power to get more throughput, then that seems like that is going to be a fruitful area that will disrupt the industry as well.
So Paul, can you add a little more about how do you use the processing to increase the throughput, the spectral efficiencies? What are the methods that people are looking at?
So basically what happens so this joint processing idea, you have a bunch of radios, you have devices that are going around, in the, coverage area of these radios, and you're actually creating the matrix of every user device to every radio. You measure what the channel is, and you invert it. So you heard matrix math is going to be this big deal. So we do matrix inversions 418 times every half a millisecond. So so it's, we're doing a lot of complex matrix inversions, and that then allows you to spatially separate. And so the more radios you put out, the more compute you have to do. It's an exponential thing. but the more devices you can separate. So each device in the coverage area of the system feels like it has the cell to itself, can run at its maximum rate over the air because there's a limitation, a theoretical limitation of how much data you can get through any single link. So we don't violate that, we just allow it to run at its maximum amount. And then because you have these, you can run multiple channels to any given device, so it's like how many layers, they call them layers, how many layers can you get of data through to any given device. And so we basically built a thing that allows you, as you add more radios, you can add more layers. So whether it goes to one device or it's separated out to a whole bunch of devices, that doesn't, that's just traditional kinds of sharing, but you can actually stack things on top of each other in a way that we couldn't before. And it's interesting because our previous CTO at Qualcomm had done an analysis on this idea of joint processing and made a certain set of assumptions that led him to believe that you could get kind of 15% improvement in efficiency, but we can get 10x. So it's pretty dramatic.
Yeah, it is true. I do believe that industrial automation, smart factory is a big applications for the wireless and edge networking technologies. Both TDK Ventures and Playground invest in Agility Robotics, which is in the middle of this domain. I think one of the challenges I see that in this area is you always have very strong incumbent. The large companies that working with the mobile operators and equipment providers, it's hard for a startup to, startup can come up very interesting innovations, but it's hard to capture the value. I would like the panelists is, what is the advice you have is, how the startup can not just create the value, but also capture the value in this space.
Well, I think that's I think that's the interesting part, or the exciting part, right? Is a startup can have a strategic exit, whether that strategic exit is IPO or acquisition. And just like my point with innovation and startups innovating in AI hardware platforms, a startup is not going to get to market and compete head on with NVIDIA, right? I mean, that's funny, right? So what's going to happen to those? That startup is going to be acquired by an AWS or a Google or a Facebook or a whoever, because those people are always out looking for the next technology breakthrough, the next big idea, and you're much more likely to find that great new idea outside than within your four walls. I mean, we just see it over and over again. You have so many smart people in the world inventing things, and you have the large corporations watching. There's corporate VCs here, I know, and grabbing that. So just like that, in Wi-Fi or wireless or any kind of connectivity infrastructure, that is a heavy lift. That is a huge capital expenditure, huge. And so to think that a startup is going to, and I don't know, maybe you'll dispute me, but to think that a startup in this day and age is going to go to IPO and then compete head on with the other technologies, it's much more likely to be acquired by one of those big folks that have the capital to turn that into an industry standard and drive the adoption curve. So, but I think that's just as exciting as a startup. The stat, right? 17% of all startups end up with a strategic exit, 1% IPO, and 16% acquisition. So I don't know, if I'm a startup, I might just target the 16% instead of the 1%, but the 1%'s fun too, right?
I think it's important that a startup either has an order of magnitude difference in terms of performance or in terms of lowering costs. So a few examples, we're an investor in a company called IR Labs that saw that the I/O bottleneck in both HPC applications as well as AI workloads was going to be tremendous. So they developed a new chip-to-chip interconnect using, again, optics that give 1,000x the performance. In fact, 4 terabits per second I/O performance at a fraction of the cost. So there's something that they immediately were able to go and take on some of the biggest high-performance computing centers in the world because it was such an order of magnitude difference. Another in the connectivity space, we invested in a company called Mangata Networks that actually is going after medium Earth orbit rather than LEO or GEO, and deploying a much smaller number of satellites. I think they're putting out 36 satellites in middle Earth orbit to cover the whole world and to be able to offer connectivity. And they're going after aviation, ports, they're going after maritime, and then data center connectivity, and again, being able to offer it at a fraction of the price. It was actually a team out of O3B and OneWeb who came up with the ability to offer satellite connectivity at a much, much lower cost. You know, I know you're going to go talk about the medical space. In the medical space, we invested in an Illumina competitor called Ultima Genomics, which their goal was to be able to sequence the whole human genome for $100 going to $10. So there has to be that order of magnitude improvement or some new architecture or new foundation that makes it so appealing to customers that the order book starts filling up early on, and that is a better way to attract investment.
So having gone at Qualcomm from startup to mega cap, we had a better idea. There was a greenfield opportunity. People, it was the transition from analog to digital, so there was opened up a lot, and the people at Qualcomm were the people who really understood digital communications. We had customers that came to us and were looking for a solution to, here was this big takeoff of analog wireless, cellular radios, and they had this brick wall. They'd actually literally show you a PowerPoint with a brick wall on it, like, oh, we're going to hit this thing. And so, there was demand, but despite that, and despite the fact that the companies that we were going at were incumbents who were slow and very protective, I would also say like luck played a big role in it too. So, the reason why it's so hard to get to that point is because a lot of things got to break your way too. So you got to work your rear off. You got to have to be the 1%, you got to work your rear off. You got to have a world-changing idea, and you got to be freaking lucky, and that your competitors mess up, and all sorts of strange things happen. Like we had a competitor that chose their speech coder, because I did that work for CDMA, and we were like, why does that sound so bad? They went through this whole competition. Well, when I went up to run hours in the same lab that they ran theirs in, I found out that the lab had messed up all the samples. So they literally randomly chose a speech coder for the competition as opposed to the best one. So it just sounded bad. And that helped us. That was another thing that helped us win. It's just like little things like that are just so, so anyway, so I guess the point is, you got to be very focused and have a great idea, and also seize the opportunities when they come, because those opportunities, that's how you're going to wiggle through and find your way. But it's still extraordinarily hard. So
it is very true that as an entrepreneur, you have to be very focused and persistent to get to the finishing line. We touched a bit about the medtech space. We already see many AI and ML companies in this space, especially in the image processing applications for detection and diagnosis. So Diane, I would ask you, what are the unique computing and connectivity innovations in this space, and what are the unique challenges you see for this particular use cases? Yeah.
Yeah, thank you. So first of all, if you just think about the healthcare space, it truly is the last industry to adopt technology. It has been so difficult. When I was back at Intel in 2012, I owned Intel's vertical healthcare segment, and our whole objective was to just focus on that one segment and try to get them to adopt electronic medical records. And it took 25 years to get them to adopt EMR, to get to 90% of all hospitals and clinics. It took 20 years. It was crazy. So now here we are with MedTech, and finally they're waking up, and a lot of it is because the innovation that's occurring in other industries you just can't ignore. Here's how bad it is. So your physician today still is convinced he's smarter than any technology, right? He's went to school for 10 years, and there's no way that some AI system or some robotic system is ever going to know the right answer better than he does. So you walk in, if you think you're having a stroke, you're either going to call 911 or you're going to walk into an emergency room and say that I think I'm having a stroke. They're going to then do a clinical exam where they tell you raise your arms, smile, speak, gait, and then from that clinical exam that was invented in 1998, they're going to decide whether or not you're actually having a stroke. And guess how accurate that assessment is? Clinical data supports how accurate is that assessment? 50%, flip of a coin. I mean, why even bother? Just go, yeah, no, right? So our, not to talk about our technology, but I obviously know it well, our technology uses a robot to find the thin spot in your skull, then uses AI algorithms to read the cerebral blood flow, to read the blood flowing through your circle of Willis, and determine the velocity of that blood flow and whether or not there's an occlusion, whether there's emboli flying. And in less than 5 minutes can say, the guy's having a stroke, he's not having a stroke. Why not just do that, right? Why have people waving their arms? And the time it takes, median time today from when you think you're having a stroke to when you're treated is 4.5 hours, that's median, and every second you lose 2 million brain cells. So your brain is just deteriorating every single minute. So it's just crazy. Like, why not just adopt technology? This is it's ludicrous. The one big reason that technology doesn't get adopted in healthcare is reimbursement. So the hospital says, I have a doctor that can do this, and I don't have to pay for him to do this. If I have to buy this medical device and this cloud computing solution and the app, it's on top of what the doctor's already doing. So I'm just increased my cost to get the same exam completed. Although with the AI and robotics, it's 96% accurate, clinically proven, versus 50. So now you've got to convince them of an ROI that's around better patient outcome. Wouldn't you want more people to survive? And then, well, how do you dollarize that, right? It all comes back to, for the hospitals, at a positive ROI. And then, of course, you've got hospitals, physicians who, it's a change management issue, trying to convince them that they should change their behavior and change their practice. So between the hospitals wanting more money and the physicians wanting no change, it's ridiculous. We all suffer from the lack of technology adoption in hospitals. From getting back to your question, now for your question. From a computing and connectivity perspective, you got to admit, if you're a really smart cybersecurity IT guy or really smart connectivity networking IT guy, the last place you want to go work is a nonprofit hospital. No stock, no chances of upward mobility. I mean, you talk about, so talent, of all things, becomes a huge limiter to in this industry staying up to speed. And so, as I said, cybersecurity risks are tremendous. They're very, very fearful. The networks, they won't let any devices on their networks. So here you're trying to build out an IoT system so that every healthcare practitioner has their device wherever they go, whatever they do, and they can see instantly the exam that's happening on the patient. But oh no, you can't connect to the hospital network because of risk of cybersecurity risk. So there's a huge need, and I think all of us that have used our healthcare system know that there's a huge need to advance security, to give them the confidence, to advance the networks, which when our solution is real time from the device to the cloud down to the app. But inside the hospital, instead of 25 milliseconds, it takes a minute because the network is so slow and archaic and overly controlled. So it's really sad because we all engage in the healthcare industry, and it could be so much better with broader adoption technology. Predictive analytics, I mean, why wait until you have dementia? Why not tell you 20 years ahead that your blood flow through your brain is slowly degrading and get some kind of proactive treatment? Predictive analytics would go so far in the healthcare industry if there would just be broader adoption. It's crazy, crazy.
Yeah, I mean, thank you, Diane, for sharing some very practical challenges in adopting AI in the specific, your industry. Laurie, you look at many AI ML companies. Would you shed some light on the pitfalls that you see startups that failing to get the AI adoptions for particular use cases?
Sorry, I'm not sure I understand.
So can you shed some light on what are the typical pitfalls for startup in the AI ML startups to deploy their technology?
some of the issues that I think the industry is grappling with, as we talked about in the previous session, is the biased data. If you are using one of the models that is outside of your company, one of the large language models built by others, there's a big concern that enterprises have if they, for example, put their code into one of the models or put their data out. Who owns the data? As John Hennessy spoke about earlier, the copyright concerns, if you haven't seen the Getty Images lawsuit against some of the image generators out there, what is the model training on? Where is the data coming from? Who owns that data? Who owns the output of whatever is generated? There are a lot of those issues. And so Mosaic ML that I talked about allows a company to build their own model, training with their own data, and not having to pull in data from other places. And so a lot of enterprises are much more excited about being able to have more of that control the output, and control the training data. Bias is, of course, always an issue, even within companies, but there are some also tremendous benefits that one sees in terms of one of the uses that a lot of folks are very excited about is being able to go across all of the data sources within a company, being able to do retrieval and being able to summarize that data or normalize across all of that data. But the concerns around bias and copyright and ownership and privacy are still of great concern in the AI ML world. And then, of course, as I talked about earlier, energy utilization for those very large models.
What I see as the biggest problem for startups in AI, as a person that grew up in hardware, maybe it's easy to poke fun at software people, but is the startup fundamentally has to have a moat. Like one of the three fundamental criteria around a value of a startup is that you built some moat, you have some intellectual property. And the problem with software AI companies is you can't patent the algorithms. And the data sets, maybe you're lucky enough, as was said, to own them, but that's hundreds of millions of dollars. How many startups are going to be able to spend that kind of money on data sets? And so what is your core differentiation between you and the next guy? And we saw this in the radiology space, in image recognition, in reviewing x-rays in identification of cancer and cancerous tumors. And there was the first to market, big industry leader, I won't say names, but big industry leader, first to market, at a certain price. It was $100,000 a year for a subscription to a hospital. The number two guy came out, dropped the price to $30,000, and the market flipped from 90% to the first guy to then less than 50% of the market, flipped overnight. Because AI is AI, image recognition is image recognition, data sets are data sets, once it's trained it's fine. So it is really difficult, and I think you really have to stop and think, what is that core differentiation? It's the intelligence of the people programming, right? It becomes who can get the best talent, who has the smartest talent, or who can actually find that high quality data set and maintain it as a proprietary asset. But it's very hard to come up with a real moat, I think.
Certainly at the app layer, that's going to be tough, right?
Yeah, I'd say, the only thing I'd add is, we're going through this whole debate internally about using Copilot and having code generated. Is this a big disadvantage to us if we don't use it? But on the flip side, if you use it and then some court holds that you've now incorporated open source code in your stuff and you lose your IP and that, so right now we've come down on the side of not using it, but you recognize that has its disadvantages not to use that. So that's another thing. I think until the litigation is settled, we don't know about copyright and open source and how it's going to apply to these things, this generative AI generated code.
Yeah, this actually touched the question I want to ask before we go to the Q&A session is, I was surprised that Dr. John Hannesen mentioned that he used ChatGPT to write draft for him, basically, right? And Palo, you share your perspective on that already. I want to ask the other two panelists, do you have any experience of using ChatGPT or some kind of similar tools to to help you to improve productivities? Or you have the same concerns?
Can I just say what I do use it for?
What do you use for? Yeah.
Haikus, limericks, and knock-knock jokes.
Yes, I was going to say.
Don't we all do that? Like, how many limericks have you guys all made with ChatGPT? Come on, admit it.
Or Christmas cards. I got a lot of ChatGPT generated Christmas cards. They seem good for that.
I got a really, really cute poem about a bear and a rocket that are best friends because my friend's child loves rockets and loves bears. So I said, write a poem about a rocket and a bear that are best friends. It was adorable, but high value, right? That's why I say generative AI is 10 years out, but for now it's fun.
I will say, though, I have a number of friends who are lawyers, and they said that it is extremely useful for first draft of a contract. I mean, there isn't that much that changes in a contract or an NDA or summarizing some kind of legal structure. There isn't a lot of creativity in proprietary data, so why not do the first draft and then put in the proprietary data yourself? So I will say in the legal profession, there is quite a bit of use of ChatGPT to generate first draft documents.
But to be fair, like in a legal contract, you really want to make sure that it's right. Like, litigation turns on very small numbers of words, and you're like, did you interpret it this way or that way? What was the intent? What was the intent? Like, what's the intent of that generative AI? I don't know. I don't know. I'm a little cynical about the whole thing because you start out with a little prompt and then you end up with tons and tons of verbiage. I'm like, that's like the opposite of a compression algorithm.
Yeah. So I would open up to Q&A. Any questions from the audience? So, Jeff.
You've all had the chance to sort of run major enterprises, run aircraft carriers, and now you're doing different types of roles. And I'm just curious, which is more fun? I mean, maybe particularly from Paul and Diane, I'm sure there were frustrations in both, the big job, if you will, and the job now that you're doing. But which allows you to get more excited when you get up in the morning, and why?
Like I said, I started at Qualcomm when it was small, so I lived through that whole part of trying to fund the company, although I wasn't doing that directly. I was an engineer at the time, but I knew what was going on. I would say you spend an inordinate amount of your time in a startup fundraising, and that is, I think, the worst part of the job. But on the other hand, in a big company, you spend an inordinate amount of your time on investor relations, which is probably similar.
Yeah, no, I think you said in a big company, you spend most of your time on PowerPoint, which is also equally frustrating. But going from entrepreneur to entrepreneur, the obvious similarity there is you have to keep inventing or you'll die. Even inside of Intel, we have here someone from our silicon photonics team. We started a silicon photonics team inside of Intel for next gen connectivity. It went from $0 to $250 million in revenue within the year, and it was wildly successful. So whether you're in a big company or you're in a small company, if you aren't continually inventing, you're going to die. The other side of the coin, though, is that where it becomes difficult as a startup is, number one, I hate fundraising too, and that's why I started by saying if anyone could just give me capital and I don't have to knock on your door, that would be great. But in a large company, I had, in the data center group, I had 10 product lines, servers and storage and network and Ethernet adapters and whatever. And so it's highly complex, obviously high return. You go into a startup and you have one product for one target market with one customer base. And so life is so simple. It's so simple. It's hard to even believe how simple it is, except that you have single point of failure. Right? If that one thing goes wrong, the whole company's gone. So it's simple and stressful. Very crazy.
The other thing that at Qualcomm I was able to do a lot of internal projects. So even before becoming CEO, so that was actually fun. You had to fight the finance organization to make sure that you could get the funding for it. But there was a period of time at Qualcomm where the investors wanted us to have non-revenue generate, things that were more than 2 years away in terms of generating revenue. And that was kind of like a golden period. And we invented a lot of stuff during that time, things that, absolutely changed the devices that we carry around with us because we had that freedom. And I know, dealing with like nonprofit research institutes, when they're curiosity driven, you get like these amazing results out of that. So I would say, in the big company, if you have the ability to do that, which we had for a time at Qualcomm, I think that was probably the most productive time of my career and probably the funnest.
So a question here. Oh, yeah, we'll go over there. Then come here.
I think my question is probably a little bit more toward Dr. Jacobs, who has been instrumental in bringing connectivity solution to our world. I actually learned this fact from a very brilliant entrepreneur here who is actually sitting here today. Henry and I actually co-invested in this company together. With the telecom industry overall, from 3G to 5G, largely consolidated. And coming with that is a lot of consolidation of telecom equipment. And today, we actually don't really have a telecom equipment provider in North America. It's actually Nokia and Ericsson, and that 1/3 of the market is actually being controlled by Huawei. So as the world becomes a little bit more deglobalized, how do you think the reshoring of the technology, where do you think we should innovate and invest as a community?
Yeah, that's a great question. It's one that we're focused on at XCOM because, we have, the hubris to think that maybe we could be the seed of a telecom player that could be a national champion in the United States. And the thing that I believe is that the way that the U.S. wins in general is through innovation. So it needs to win again through innovation and not just doing the same old. And what I said before about having a horizontal market where you can sell into, I think that helps a lot because the buyers, the mobile network operators, they've also consolidated a lot. And the period of time it takes to get through a mobile network operator is very long. And they don't really want to bring on new vendors that easily and so forth. So having the horizontal market that allow you to build out an equipment manufacturer and innovate to solve the problems that these various enterprises have. So that's the way I look at it. And then I think, at least from our standpoint, we see a lot of companies that are doing innovation in the space and need a platform to put those innovations on top of. So that is one of the goals that we have as well, is to try and be sort of that catalyst where that can come together. And there's a lot of interesting things going on, but it is hard to compete against an incumbent. We had a case where DoD was trying to incentivize small companies to come out and build new innovations, and they created a test bed down in Coronado, and they wanted a smart warehouse. Well, the test bed, which was supposed to be Open RAN and allow us to put different things in it and on top of it, ended up being won by Ericsson and AT&T. And I can tell you, none of the people who were working on network innovations got the next grant because it was absolutely impossible to innovate on top of that platform. So now it's hard for them as well. Those big companies, it's hard for them to innovate on top of their own platforms too. So I think that creates an opportunity. But like you said, it's hard to compete against those big guys. Yeah, and then just to close with what I started, innovation is the key. So if you can do something better than they can do and you can sell into a market that they haven't locked up, that's the best way to do it.
Yeah, just quickly to add, I'm not sure I worry so much about your worry. It is an insightful observation. But when cloud became so popular, and way back in those old days when cloud was becoming popular, the OEMs, right, the original equipment manufacturers of servers, became UCPR, unnecessary crap per rack. And that was the acronym used because you're just wrapping sheet metal around innovation that came from NVIDIA or Intel or Broadcom or Qualcomm. All you're doing is a sheet metal wrap. And so you're not really providing that much value. So the TEMs, you're right, that market has dwindled down because it's a tough place to be in. So rather than think about the TEMs, the Ericssons, and the Nokias as the guys that are delivering the equipment manufacturers, think about what's inside those boxes. That's where the value is. they're wrapping the sheet metal. And if we want, Finland and Sweden to wrap sheet metal, I think that's fine. Are they Finnish and Swedish, or Swedish and something? Where's Ericsson? So I'm not so worried.
Question for Paul and Diane. Sanjeet, ex-Intel Capital, now running UFOS Capital. If you were running Intel today, how would you restructure it? and what would you focus Intel on today? No, I would like Paul's point as well. as a Qualcomm ex-CEO,
Well,
what's
we
your
sent a few
viewpoint?
Qualcomm people over there to help, but that didn't seem to work.
Yeah,
They
did hire, yes.
Very, very different cultures, honestly. I mean, it's, look, when we started doing CDMA at Qualcomm, Intel was our fab. And the very first CDMA chips were x86. And Intel thought that they were going to take that and stuck it to us, and we went to ARM. And that's basically how ARM got its start. I'm not trying to be a jerk. I mean, it's what happened. Yeah. No, but yeah. So, now it's interesting that the idea is to try and go to a fabless model. Look, there's clear benefits to the fabless model. It's not clear to me yet whether Intel's going to be able to make, catch up again. Because when you have TSMC and Samsung run by you very fast, it's not like, when they run by you, say, okay, well, I'm going to now run faster than them and get past them again. It's like that's not a short process. So I don't know enough of the internals of their foundry to know whether they will be successful at that. For sure, the U.S. is trying to give them some money to help them do that. So I think that's, you'd have to be more on the inside. Maybe Diane knows better than me.
No, I haven't been there since 2017, so I probably don't know much better. But I will say, number one, your point made. Moore's Law, they lost the lead. Intel lost the lead in Moore's Law in 2013. You don't catch up, right? That boat, that ship has sailed. There's just no way all of a sudden you leapfrog and gain back 5, 7, 10 years. It's just impossible. So maybe it wasn't 2013, it was probably 2015, sorry. But anyway, you're not gonna make up that time. That time is gone. The other issue is I heard probably the best assessment of what Intel should do or what happens to Intel on Squawk Box, where they said, as someone that was being interviewed said, you take the entire semiconductor market and you divide it into 3 pieces. One is the low end, the stuff that's in your refrigerator and your washer and dryer, right? Give that to China. China will be able to play in that space. Then you take your super high end, latest and greatest, maximum performance, that's TSMC. And then they said, and Intel can have that stuff in the middle. And as a 32-year Intel vet, that was like a dagger to the heart that here we are now relegated to, that stuff in the middle. But it was probably the most insightful and accurate assessment, because once you've lost lead, you're not going to catch up. Play where you can.
That's kind of global.
So I would like to take the last minute from the audience. If there's a question from online, I will take that as well. Nan?
Yeah, I have one question for Mr. Jacobs. I'm Nan with Qualcomm Ventures, and it's such an honor to see you in person today. And all Qualcomm Ventures investors and partners are a huge fan of Mr. Jacobs, so am I. So the question today is, Qualcomm is such a category definer during the mobile internet era and 5G connectivity and everything. But now we're entering into the era of generative AI, and I think NVIDIA and Microsoft are on the top of the pyramids right now. So where do you see Qualcomm's position in the next 5 years to capture a good market in generative AI? Thank you.
So Qualcomm's been a pretty good performer in AI. On the various competitions, we always did reasonably well. I think there is definitely an opportunity to build things into the end devices, because there's things that you want to happen with very low latency and so forth. So I think there's opportunities there, and I think there's opportunities. Cristiano's trying to take the company into a set of new markets. The question is, do those markets grow fast enough? I think I wouldn't give up the smartphone market so quickly. I know that there's definitely MediaTek's been taking share, and there's various things that have caused that to happen. But I don't feel like they've lost their way. I do think, though, and one of the reasons why I wanted to take the company private was I felt like, there was way too much close-in thinking and not the far-out thinking, which is what allowed us to generate high margins and feed the innovation engine over and over and just keep the cycle going. And I think that was a huge mistake of the management team that followed me, and one of the reasons why we were trying to take it private. I mean, we thought that the market had mispriced that asset dramatically because it was looking way too short term, and there were opportunities in the future. With Apple and now with Google doing their own chips, I mean, it's just made it much harder. So I think Cristiano's probably he's playing the hand that he has as well as he can, but it's just going to be a timing issue.
He could have let Broadcom acquire him.
Yeah, look, I mean, Donald Trump got in the way of that one. That deal was pretty well cooked until the president got in the way of it. So, yeah.
So I will take the last question probably from online. Andrew, we have any questions online?
Yes, we do. And the question is from Ali. And the question reads, are there any government initiatives or programs or regulatory bodies to regulate data sets or training practices of company-owned AI models?
I mean, it's a niche, but I can speak to the healthcare market because data is, such a big deal in the healthcare market. The regulatory statement around data in healthcare is that if you can prove that the data will improve the efficacy, sensitivity, specificity, accuracy of whatever that healthcare device is, then you own the data. So if, Kaiser has a medical device and it's generating data, it's generating their patient's data every time they do an exam, that's obviously the patient's data, it's obviously the hospital's data, but FDA says it's also the company's data that is developing and building that medical device, because that data through AI can continue to improve the results. So I think that was shocking to me and actually quite generous, because now every hospital that has our system, we have to de-identify it. That's obvious, right? But the data that's of value is actually owned back by the company that owns the original device. Pretty nice. Pretty forward thinking of the healthcare industry around AI. Who would have thought?
Laurie and Paul, you have anything to add?
There are a number of initiatives. I know that there's an initiative called NAIR at Stanford, and I know that a lot of my friends who are academics are making a lot of trips to the White House right now as these kinds of policies are being formulated. I don't think it's really easy to move quickly and just say it's going to be this way in every industry. So I think it's a fairly complicated issue, but I know there are many, many discussions and coalitions that are happening right now.
I mean, so I think Europe's been pretty focused on data privacy for quite some time, and almost to their detriment. So I was working in a company that was in healthcare, and there was this issue of the amount of time that you could keep data about a patient in Germany, which was so short that they couldn't even tell whether their dialysis centers were actually killing people or not. I mean, we're going to have to find some kind of a balance, and I for sure agree. And I'm on the board at Dropbox, as you heard, and Dropbox is very one of their key attributes is they don't let their your data that's in their systems be indexed and computed on, but also understand that you want to be able to get AI to work on your data, but hold it for yourself. So I actually think the market is going to drive some of this kind of stuff as well, that the regulator will be probably behind, as they often are, and come back later with hindsight and regulate. But I do think the market's going to be very sensitive to this issue about how much of your information is leaking out because it was used as a training set. And so that may be more the solution.
Thank you. Thank you, Paul, Diane, and Laurie. This brings to the end of this session. We covered a very broad spectrum of topics today, from AI to cybersecurity to edge device and edge networks, quantum a bit. I would like to extend my final sincere thank you to our panelists for taking the time, share your insight and passion. and also to the audience for both in person and online. For the in-person audience, our next session is happy hour and cocktail party. For the audience online, I want to remind that DX Week will move to Tokyo, Japan on Wednesday, local time. We'll have Mr. Tako Asami-san, the Senior VP of Research and Advanced Engineering of Nissan Motors, as the keynote speaker there. Now, he's going to talk about the exciting topic of the future of mobility. Thank you. Thank you, everybody.